We're going to discuss some quadratic function characteristics. Remember, every quadratic function follows the form of y equals ax squared plus bx plus c. And the values of a, b, and c are all just real number constants. And there's a few things that happen with those graphs when we change the values of a and c. So a determines whether this parabola, that U shape, opens up or opens down. If a is positive, the parabola is going to open up and it's going to have a minimum value. So it's going to look something like this. And that minimum is going to be right down here at this point, meaning that the parabola is not going to go anywhere below that point. If the a value is negative, the parabola is going to open down looking like this, and it's now going to have a maximum value up at that point, meaning no part of the parabola is going to go anywhere above that point. These maximum and minimum values are also called vertex points of the parabola, and we'll talk about those a little bit more later. If the absolute value of a is greater than 1, then this parabola is going to be narrower, meaning it's going to be a very skinny U, whether that's opening up or opening down. It's going to be very skinny. If the absolute value of the a is less than 1, it's going to be a much wider U, so looking something like these parabolas. That c value at the end is going to shift the parabola either up or down from the origin. Now looking at a few examples of these. So this is a picture of the equation of y equals x squared minus x minus 2. Now I can rewrite this as y equals 1x squared minus x minus 2. So this parabola is opening up, and it's opening up because this a value right here is a positive 1, which is also creating a minimum value right down here at this point. So that is a minimum, and it is also the vertex of this parabola. This parabola is also shifted down from the origin, and it's shifted down from the origin because of this negative 2. So notice how my parabola has gone down 2 units from that x-axis, and that's because that c value is a negative 2. Now in this example, I have an equation of y equals negative x squared minus 2x plus 3. I can also rewrite this as y equals negative 1x squared minus 2x plus 3, because if I have a negative sign in front of something, it's actually saying negative 1 times that something. So in this example, we have an a value of negative 1, so that's why my parabola is opening down, and I'm having this maximum value right here at this point. So this is my maximum, and it is also my vertex point of the parabola. Now you'll notice in this parabola that I have shifted up 3 units from the x-axis, and that's because the c value is a positive 3. Now there are ways we can find the vertex from a given quadratic equation. So I have this quadratic equation of y equals negative 3x squared plus 12x plus 1. I can find the vertex, the x value of the vertex, by doing negative b over 2a. So remember, b is the term that is attached to the x, so that'd be a positive 12 in this example. And a is the term that's attached to the squared x. So in this example, it would be a negative 3. So to find the x value of my vertex, I take negative b. My b value in this example is a 12. So I have negative 12 over 2 times my a value of negative 3, which would give me negative 12 over negative 6, or negative 12 divided by negative 6 is a positive 2. So this is my x value. Now to find the x value, to find the y value, we take this x value and we're going to plug it into our original equation wherever we see an x. So now I can find the y value by doing negative 3 times 2 squared plus 12 times 2 plus 1. Remember, whenever you plug a value into an equation, always put it in parentheses. Now I need to follow order of operations and do squared first. So I have negative 3 times 2 squared, which is 4. I can also do my multiplication of 12 times 2, which is 24, and then I have a plus 1. So then I'm left with negative 12. 24 plus 1 is 25. So then I have negative 12 plus 25, which gives me a y value of 13. So my vertex of this quadratic function right here is happening at x comma y, which would be 2 comma 13. In this other example, on b, we have y equals 2x squared plus 4x minus 1. So to find my x value, my vertex, still following this equation, I have negative b. My b value is a 4, so I have negative 4 over 2 times my a value of a positive 2. So negative 4 over 4, or negative 1. Now I'm going to take that x value and plug it into my function wherever I see an x to find the corresponding y. So y is going to be equal to 2 times negative 1 squared plus 4 times negative 1 minus 1. So then I have y equals 2 times 1, because negative 1 squared is 1. I can also do 4 times negative 1 in the same step to get negative 4, and then I have a negative 1. So then I have 2 minus 4 minus 1. So then I have a y value occurring at negative 3. So the vertex of this quadratic function in x comma y is negative 1 comma negative 3.